Hello, I'm Anna Mackay and this video is on compound interest, and it's actually in the section of sequences and series, not in a financial maths section. It's an application question here. So suppose you have $1,000 in a bank account that offers a rate of 10% per annum compounded annually. At the end of the first year, how much will you have? So you have to imagine we're taking that $1,000, we're increasing it by 10%, which means we can use a multiplier of 1.10 or 1.1 to work out how much we'd have. So our T1 in this sense is 1,000, using our terminology from sequences and series. Our multiplier is 1.1 to give us a total value of $1,100, and that becomes T2. That's what's happened after that first year. Following on with that, at the end of the second year, how much will we have? We would start with that 1,000 and multiply that by 1.1 and multiply that whole answer by another 1.1. Written out neatly there, you can see it as that, and you will identify that that section is actually T1. The 1.1 is multiplied twice, and using your law of power laws, that's 1.1 squared. So that becomes our third term. So T3 is equal to $1,210. Notice that the power that we had there was power of 2, and this helps us identify term 3, thinking about the connection between those. Third year, to check that what we're doing is on the right track, that $1,000 multiplied by 1.1 for 3 years, which can be written as 1.1 to the power of 3, and that is at the end of our third year, so that will be T4, giving us the total of $1,331. So at the end of the nth year, apologies for the notation there, what we should have is that the Tn, well, I'm going to write it for the Tn term first. What we've been working on there is it was the $1,000. I think my face is going to be in the corner, so I'm going to start that up there. The Tn term is $1,000 times by the multiplier 1.1, but which power is it? Notice that each of these, if it was the third term, power of 2, fourth term, power of 3, so it should be to the power of n minus 1. If you want to write that in the format t to the n plus 1, as is written down the bottom here, very similar. Look at what changes. We did have n in the Tn term there, and now we have n plus 1, so our n component has been increased by 1. If we increase this section, the n minus 1, increase that by 1, that becomes n. And so that's the recursive formula. Summarising that, we can calculate the value of a compounding investment using the formula here. Either form is fine, the Tn plus 1 form or the Tn form. Both are handy to know. You may use them slightly differently depending on how the question is worded. T1 is our initial investment, where R is the multiplier for each year, so we had 1.1 in the previous section. N is the number of years, and Tn plus 1 is the amount after n years. One example here, we have money invested for 4 years at 7% per annum, compounded annually. Notice that this application here is compounded annually, so very straightforward types of examples. What will it amount to at the end of this period, giving our answer to the nearest cent? So after 4 years, we have to allow for T5. Remember, T1 is after no time has passed, so after 1 year has passed, then you're after T2. So that number there is always one more than you might expect. So for 4 years, it's actually T5. We have our initial term multiplied by R to the power of 4. That's our n take 1. Thinking about what our multiplier is going to be, with 7% there, we'll have 1.07, and our T1 is our initial amount of $5,000. Giving our total amount there, with a dollar symbol, $6,553.98. Always good to answer in a sentence. If it asks you in words, what will the amount what will it amount to at the end of this period? The investment will amount to that much money. So if you liked it, give it a thumbs up and subscribe to the channel, and the next video will be 10D series. Thank you.